Hi everyone, I'm going to talk to you briefly about how the Ribble Rivers Trust are using SCIMAP and SCIMAP-like tools to spatially target the creation of woodlands and hedgerows across the Ribble catchment. So as you all know, resources and funding and time are all very limited, so we need to make the best use of what we have available. And so at the Ribble Rivers Trust, because we have limited resources, you do want to create or improve habitats in the locations where you know they're going to have the maximum positive impact on the environment and the wildlife and the people that are within that area that you are working in. So at the Ribble Rivers Trust, we try and take an evidence-based approach to where we do our habitat creation or improvement works, again, so we know that they're going to have the maximum benefit possible. And so first of all, I'm going to talk you through a model that we produced that helped us spatially target where we were going to create new riparian woodlands within the Ribble catchment. And this was a model that covered the whole of the Ribble catchment, which is over 500 square miles, so it's a big catchment. And so we approached SCIM, we asked SCIM to produce a tool for us that would help us map the risk of sediment input, faecal matter input, and the risk of flood generation across the whole of the Ribble catchment. And this is the tool that he produced for us. It utilises the principles of SCIMAP. And the output of this tool is this data set, which is a points data set that consists of a point every 5 metres along every watercourse across nearly the whole of the Ribble catchment. And each of those points has a series of values associated with it. And so there's more than I've listed here, but the 3 that we're going to talk about today is these 3 I've listed. So each point had a relative risk of faecal matter input associated to it, and so that risk was relative to all the other points within the catchment, and that was calculated based on the watershed that fed up to that individual point. And then each point also had a score which represented the relative risk of sediment input at that particular point in the watercourse, and also the relative risk of flood generation. And so in total in this data set there was getting on for 500,000 points, which is a lot of data, and that's just because it's such a fine resolution, which gives a lot of detail to work with. And so I was tasked with taking this tool and producing a model that would help us to determine which locations we should prioritise creating new riparian woodlands, where they were going to have the greatest benefit on the Ribble catchment for reducing any of these risk factors. And so I'm not going to talk you through the step-by-step process of how those models were created, but I'll talk about the general principles. I'm going to run through the process as if we were modelling where there was a high risk of flood generation on watercourses, but it was the same process for sediment input and faecal matter input as well. So the first stage of the process was to take this huge points data set and extract out those points that had a relatively high risk of flood generation, and discard those that had a relatively low risk of flood generation. And this gave, it probably doesn't look it there, but a much reduced down data set. So this now contains between 6,000 and 7,000 points instead of nearly 500,000. And if we just zoom into this particular area, you can see that on some stretches of watercourse there's just an individual point that has a high risk of flood generation, and in others there's longer chains of points all next to each other, all of a relatively high risk of flood generation. And so those longer chains of points, which correspond to longer stretches of watercourse, those are the ones that we're interested in creating riparian woodlands along those stretches of watercourse, because if you create a woodland all along that stretch of watercourse, you're going to have a greater additive effect on reducing the risk of flood generation in that area than if you just target smaller stretches of watercourse. And so the next stage of the model was a series of analyses that first of all separated these longer chains of points or longer stretches of high-risk watercourses from those just individual points, and then identifying which of those longer chains were significantly longer. So in essence what we were trying to do was to identify the longest stretches of high-risk watercourses within the whole of the Ribble catchment, and so those would benefit most from creating riparian woodlands. And so this is the result of the model when it was run for identifying the stretches of watercourse that had a high risk of flood generation. And so this one that I've highlighted, you can see that it corresponds to a stretch of 120 metre watercourse, which has a high risk of flood generation all along it. And so that whole modelling process was repeated to map the watercourses that had a high risk of faecal matter input, and also sediment input. So each of those output data sets, even though it's a much more usable data set to use now, we can really see where those high risk points are. There's still quite a lot to work with. Each of those data sets has maybe between 30 and 50 priority locations. So that we're getting on for nearly 150 priority locations where we want to create riparian woodland. So where do you start? And we actually noticed that there was some overlap between these data sets. So a stretch of watercourse that might have a high risk of flood generation may also have had a high risk of faecal matter input or sediment input, or any combination of those three. And so the next stage of the modelling process was just to highlight where those overlaps were. So a map similar to this one was created, and so it helps you identify where, if you created riparian woodlands along particular stretches of watercourses, you could actually help reduce the risk of various risk factors, and so have multiple benefits for the river. So, for example, if you planted on the dark red stretches of watercourses that have been identified, you could reduce the risk of faecal matter input, flood risk, and also sediment input, instead of just one risk factor. And so what's interesting is, having looked at the results of the models, some of the locations where it picks up as a high-risk location actually matches what we know based on our local knowledge. So, for example, a model might say that a stretch of watercourse has a high risk of sediment input, and we know that there is quite a lot of sediment entering that stretch of watercourse. And in some other cases, we were still planting woodlands while SCIM was developing the tool for us, and while we were creating the model from that tool. And during that time, some of the woodlands we planted actually matched up with the priority locations that came out of the model. So this is a site. This is a site at Stainforth, where in the winter of 2014 we created a woodland, and then when the model was finished it said that that stretch of watercourse had a high risk of flooding, so it was great that we just created a woodland there. And so looking forward, these models will help to direct where the Ribble Rivers Trust creates new riparian woodlands within the catchment. Of course, it has to be subject to ground truthing. We have to make sure that what's happening in reality is what the model suggests. And then we're hoping that eventually the initial tool that SCIM created for us could become available countrywide in the same way that SCIMAP has, because it's been really useful for us, and then so no doubt it's going to be useful for other organisations, but you have to ask SCIM about that. I don't know. So that was a quick run through of how we've used a SCIMAP-like tool to spatially target where we'd like to create riparian woodlands in the future, so that they have the greatest benefit for the rivers, the wildlife and the people of the Ribble habitat. I'm just going to finish by very quickly running through another model that we're currently developing to target where to recreate and restore and create hedgerows across, again, the whole of the Ribble catchment. And well, we know that hedgerows are really important for interrupting overland flow paths, reducing the amount of water that enters rivers and the amount of pollutants that get into rivers, and they're also just fantastic habitat for wildlife. So again, we wanted to create a model that helps us target where we're going to recreate or create hedgerows, where they're going to have the maximum benefit. As I said, it's just in the development phase, so I'm going to briefly run through the principles of how the model will work. And I'm going to use this particular farm to highlight how we'll do it. So we know where existing hedgerows and other boundaries are within the Ribble catchment, because we can use Ordnance Survey maps, other Ordnance Survey data or aerial imagery. And we can also work out where boundaries used to be through the at various points in time through the use of old Ordnance Survey maps, like this one from 1937. And if we overlay these different data sets and maps, you can see where there used to be hedgerows or boundaries within the catchment, where they no longer are. So for example, on this farm, you can see that there used to be two boundaries within this particular field that are no longer there. And having been to the farm, we know that this is the case, and you can see a few remnant trees that used to be in a hedgerow that's now grown out. And so if the whole of the Ribble catchment, we can create a data set that shows where there used to be hedgerows but there no longer are, and then overlay SCIMAP over the top, you can see where some of these past hedgerows or boundaries, had they still been there, would have intercepted flow paths, but because they're not there, they don't. And so it creates a strong argument for recreating those hedgerows or the boundaries and just recreate them as hedgerows now. So we've been to this field, we can see that there is a flow path that runs diagonally across it, and as I've said, we can see that there used to be a hedgerow there. And so this would be a really useful tool for helping us to target where we could recreate hedgerows, where they're going to have the maximum benefit for the rivers by interrupting flow paths and so stopping the amount of sediments and water entering the river. We'd also hope to further improve the models so that we could prioritise where to create hedgerows, so they're going to have maximum benefits for wildlife as well, so where they'll connect up existing hedgerows or create habitat corridors, or of course where we shouldn't be creating hedgerows because perhaps this field, it isn't, but perhaps this field could have been really good wading bird habitat and you don't want to be creating hedgerows and encouraging predators to come in, and which could have a detrimental impact on the waders. So the aim is to develop models that not only identify where recreating or creating new hedgerows would have the greatest benefit just for the rivers, but also the wildlife of the catchment. And also, just having maps like this, we found a really good tool for engaging farmers, for helping them to understand why we want to do certain habitat works on their land. There's reasoning behind it, but it's not just because we want to create a hedgerow here because we want to. And also, hopefully persuade them that it's a good idea, and also perhaps maps like these could be good evidence for if they want to apply for hedgerows and boundaries grants. So we just find that having maps like this is really useful in general. So yeah, as I said, this model's still very much in the development phase, so I don't have any results to show you, unfortunately, but if it is something that you think is interesting, and it's something that we at the Ribble Rivers Trust I think is going to be really useful and we're quite excited about, then just let me know. I'll be happy to keep you updated with how it's going and what the results are. So that was a very quick look at how we are using SCIMAP and SCIMAP-like tools to spatially target where we create hedgerows and woodlands within the Ribble catchment to ensure that they have the maximum benefit for the rivers, wildlife and people of the catchment. Thank you.